Priscus Baker, and let's continue where we left off. In our second part of the homework 2, for the course of design and analysis of reconfigurable system, previously we demonstrated how to display 4 bits of counter on the LEDs on an FPGA via pin planning and assignment. Now let's continue and extend this to 10-bit binary counter. As you can see, this is our Verilog code for the 10-bit LED counter and our Synopsys design constraint file, same as the previous one. The changes we made in this code are fairly evident. As you can see, the output wire count is now 10 bits, and we will be assigning the same 10 most significant bits to the output as opposed to our 4 most significant bits. As always, we finish the pin planning and assignment and create the JIC file. For this particular code, we will flash the code onto the FPGA. I would also like to make a note that our previous experiment, we only wrote on the SRAM of the FPGA. The disadvantage to that is that the bit stream that we were writing on the FPGA gets deleted if the board is switched off. Now, as we demonstrated previously, switching off the board in this case does not actually erase the code. We do not have to flash it again. That's the advantage we get from using the flash memory. Once written, there is no need to rewrite the bit stream to the FPGA. The disadvantage to writing the bit stream in flash memory is that the process is lengthy. Hence, we have sped up this bit, but you can expect this process to take anywhere from 5 to 10 minutes. Now, once we have successfully compiled the code, we should now take a look at how the FPGA behaves. So now, as you can see by default, the board is counting down. We do not have to actually do anything for the board to count down as the direction is set by default. To change the direction, as always, we have to flip the designated direction switch. Once it is done, counting down will proceed. Now, let's first click the reset button to ensure that the FPGA is counting up. Then proceed to change the direction of the counter. Now, some of our takeaways from this project includes the fact that the 10-bit counter is much more quicker than that of the 4-bit counter. This may also have to do with the inherent clock that is assigned to both the 4 and 10-bit counter. Additionally, we also realize that using flash gives us the advantage of saving the bit stream on top of the on on the board even when there is no power. Whereas on the other hand, SRAM is much faster in programming and saving the bit stream, but we don't have the advantage of power there. So that's our homework too. Thank you all. See you next time. Keep counting.